start. Okay, thank you very much for coming. So, just first, I want to just point out that this is not a research talk. This is not the research on its own. So don't expect some crazy new ideas. This is just practical stuff which might hopefully help you at some point in your work. You might also wondering where does this actually fit. So it's not software engineering. It's not systems. Everything I'll be talking about in this talk, people usually call it DevOps, which is a short for development operations. It's one of the new keywords, buzzwords, which is coming out, which came out recently. It's kind of like an evolution of continuous integration, continuous deployment, and the idea is that, maybe 10, 15 years ago, maybe even 5 years ago, there were always two separate groups of people. There were developers who knew how to build software, and then there were administrators who knew how to deploy it, run it, manage it. But as computing resources are becoming more widespread, more ubiquitous, this is no longer the case. Now, every developer needs to know something about administration, how to run VM in the cloud. And this is what I'm going to be talking about today, and this is exactly what DevOps is about. So it's about, increasing awareness of these things.
Oh, yeah. Since you are being recorded, perhaps you should be standing over there and turn your laptop the other way around. Otherwise, we will always see your back.
Okay.
Now also being recorded.
Yeah. So the problem we're trying to solve is something you've probably all seen in the past, and it's this one. I'm not sure about you, but I've used this in so many times in my life. And it's not just in research, it's pretty much everywhere. Is that you have something which really works in your environment, but once you move it elsewhere, it just stops. And the solution to that is virtualization. Why virtualize things? Well, as soon as you move beyond a single project on a single machine, once you start having multiple projects, these projects will have dependencies. These dependencies could be, in better case, it will be different libraries. In the worst case, it will be the same libraries, different versions. And now what you need to do is you need to install everything on your machine. And then as the project evolves, you need to get new versions coming in, you need to be compiling and installing them. And in the end, what's going to happen is it will be a mess on your machine. And what happens in the end is once in a while you need to wipe your machine straight, clean and start again, install operating system again, and do this, depending on how many projects you are working on in parallel. This might happen every few weeks, every few months, every few years. So the idea is to solve this problem because this is a problem. At least some people in the world believe this is a problem. So the goal really is to go from something like this, when you have a single machine, single operating system, single file system, and there's just massive libraries and applications which depend on different combinations of these libraries, to something like this. When you really have hardware, on top of that you have some runtime which allow you to run virtual machines, and then you have these compartments, these isolated islands, which have their own dependencies, but they don't really affect each other. Now, what you might say at this point is that virtualization is difficult, it's complicated, building or running a new VM takes a lot of time, and as researchers this is not something you have time to do because you have other things, you have to save the world. You don't have time to just, install operating systems. And this is exactly why I'm here today to help you with that. And I'll show you two tools which I believe ultimately can help you. The first one is called Vagrant. It's the older of the two. It's been around for a while. And the whole concept behind Vagrant is a tool which allows you to build and also share complete environments. So essentially, when we go to this image, these things, these things wrapped in dotted lines. So entire operating systems, the whole environment. Now to stress out, Vagrant is not a virtualization tool. There are still other virtualization tools like VirtualBox, VMware, and Vagrant is not trying to replace them. Instead, built on top. It's really a tool for developers. So instead, it actually abstracts away the virtualization platform you use. It also enables building of what they call local clouds. I'm sure we will have time to go into that into many details. The idea is that really you can set up multiple different machines on your laptop, on your machine, on your server, and then just connect, network them out using virtual networks and really build something which looks like a cloud, although everything sits on your own laptop. And the motto of Vagrant is up and running. And you will, at the end of the talk, you will hopefully know why this is the case. So what Vagrant helps you to do, it helps you to create and tear down virtual machines. It uses automation to provision and to configure these machines. Also enables you to set up networks among these machines. And then once your machines are ready, you can just package them up and distribute them to other developers. Now what these things mean, because I'm pretty sure you've never seen how these words are used on this site. I'll get into that. First, there are a couple of components. This is really like a dictionary, terms you need to know to actually understand Vagrant speak. These concepts are Vagrant boxes, Vagrant files, provisioners, and providers. So let's go through all of them. A box is a basic unit in the world of Vagrant, which represents a machine. So what in the past you would call the machine, virtual machine, is in a Vagrant speak is called a box. In practice, it's typically just a tarball which contains this image, all the metadata, everything you need to actually be able to run and talk to the machine. Box is then used as a base layer for the provisioning, and there are loads and loads of existing boxes which people already built up. There is a huge portal called Vagrant Cloud when you can get all these boxes, but you can also build your own, and I'll show you how. The second part is Vagrant file. This is something you as developers will be most, this is most important part for you as developers, because this is really what's relevant to your project. It marks the root of your project, and it describes what box or multiple boxes your project uses, their settings, things like networking, share folders, and it also triggers the provisioning, the configuration of the box. Since the term provisioning was used so many times already, and I haven't still told you what that is, well, first, just to give you an idea of the workflow, so you have a box, which is really the abstraction of a machine. Then, inside each project you will create a Vagrant file, which is really just a textual file. I'll show how it looks like in a moment. And then from each of these Vagrant files, you create a new VM, or even multiple VMs, which you then provision. So, what does it mean, provision? Provision is simply a different name for a set of actions which allow you to install a machine. So, if you've ever installed a machine in your life, you create a new VM, or open your laptop, you put in a CD, you attach an ISO, and install operating system. But that's not the end. After you've installed the operating system, this is blank environment. But typically, if you need to do something, you need to code. You need other things. You need compilers. If you use C, you need something like GCC or Clang. If you use Python, you need to install Python. There are so many things you need, and you'll be surprised how many of these you actually need. And provisioning really means getting from the stage when you have a clean, blank sheet operating system to a point when you have a system which is fully configured, which is all the scripts, everything you need to actually be able to use that. So in case of Vagrant, Vagrant can already have all that for you. So Vagrant has built-in support for provisioning. It allows you to configure your Vagrant boxes. Now there are multiple provisioners supported by Vagrant. The most simplest one of them is shell, simply using shell scripts, as we've done for ages. There are a bunch of others like Ansible, Chef, Puppet, Salt. These are all implementations of the same idea. Now you might be wondering why do we need all these things? Why are shell scripts not enough? I'll show you that in a demo later on. But the core concept is that the problem with shell scripts is that first of all, they are normally they are not composable unless you really pay a lot of attention to ensuring that they are actually composable. And another actually bigger problem is they can typically be only run once. Now, in a perfect world, when you create a new machine, you will only need to run the shell script once. However, we are not living in a perfect world. People make mistakes, and you can, writing shell scripts is programming. And when you write these scripts, you will make mistakes. And when you do that, these scripts will fail. Now, if you have just plain shell script, what you need to do is you need to go and figure out which point shell script died, and what has this shell script done before reaching that point when it crashed. And then maybe create a new shell script which will do everything after that, because there are some operations which by nature are not repeatable. For example, if you have a shell script which creates a new user account, you cannot simply execute it once again, because it will try to create a new user account again, and it will fail because that user account is already there because it was created before when you run it the first time. And there are other examples, especially creating folders, deleting folders, messing up with files. And that's what all these tools actually try to solve. So these tools can do, similar things to what shell scripts can do, but they have concept of transactions, and they can be rerun, and they really understand the concept of state. So they know if they run, for example, Ansible, if you run Ansible, and if it fails in the middle, you can then fix it up, you can run it again, and it will know what has happened during the last run, and it will make sure that it doesn't do all these things again. Now, I'm not saying this is not possible with shell scripts. It is, but it will take a lot more effort than doing something like this with these tools. Providers. This is really the actual underlying implementation beneath Vagrant. So originally when Vagrant came out, it only supported VirtualBox, and this is what's built in. This is what, if you install Vagrant onto your machine, this is what you will have, support for VirtualBox. But later on, because it turned out that this tool is really useful, people love it, they've added support for more providers such as VMware, AWS, this is Amazon Web Services, Rackspace, OpenStack, Docker, and the most important for us is CloudStack, which is the private cloud deployment we use here at the department. How do you use something like Vagrant? Well, it's easy. Like when you start, you just create a new folder for your project. This is where your project is going to live in. And you just say Vagrant in it, and then you just specify what box you want to use. In this case, it will be Ubuntu precise time in 1204, 64-bit. And that's done. What Vagrant will do at this point, it will generate a new Vagrant file, which will be already pre-configured. And if you don't need to do any special configuration, like setting up custom networks, sharing folders, you can simply say Vagrant up. And at this point, Vagrant will use this Vagrant file, which was initially created, and it will start a new machine. And then, using next command, what you can simply say Vagrant SSH, and you can jump into the machine and start using it. And when you are done, you just log out, you suspend the machine, and the next thing you can do is you can initialize a new Git repo in that folder, and just add Vagrant file to that repo, and commit it into your project together with all other sources. And then you can, for example, you can continue running this thing and continue working. I'm going to show you how this works because it's really so easy. I think this really breaks, the usual, understanding of virtualization, and it's something which is tedious and it takes a lot of time and it's really painful to use.
We won't take a text.
Yeah, I'll increase that. Is this
Slightly better. It is bigger. But it's probably bigger.
okay?
Yes.
Hopefully now it's visible. So, exactly what I've done before. Let's just say, I can even see first what boxes do I have available on my machine. Well, you see, this is kind of boring because all boxes I have on my machine is just the Ubuntu precise 64-bit system. This is what I've used before. So to make it more interesting, let's run something I don't have on my machine. Let's just say I also want Ubuntu, but I want the latest one, just the 64. Done. Vagrant now created in this folder a new Vagrant file, which describes how my machine is going to look like. This is essentially just a Ruby script which has loads of configuration, but by default is commented out. If you're interested, what all options Vagrant supports, you can read through that. The most important thing is that it says what box we're going to use. Just run it, we don't need anything else, so we can just say Vagrant up. And now Vagrant is going to check whether it has this box, whether it knows something about this box. It will turn out it does not, so it's going to call into Vagrant Cloud, and it's going to download this box. Now, on fast connection like here at Imperial is going to be quite quick. If you're at home, just please keep in mind that these boxes typically can have hundreds of megabytes. So on slower connections, it might take a little while.
Peter, when you say Vagrant up, how does it know which box to?
It reads the Vagrant file, so that the Vagrant file marks the root of your project.
So every time you initialize a new project, you overwrite the Vagrant file.
Now, the idea is that you have one Vagrant file per project. And then what you do is you would take this Vagrant file and you would commit it, you would keep it inside your Git or SVN or your repository together with your project. It's really part of the project. So now Vagrant is just going to start the machine, set it up, set up SSH keys, everything you need to do. We'll also mount folders. Now I can say Vagrant SSH. And yeah, I'm inside my virtual machine. And now I can just use it and do whatever I need, start coding. We'll just go back to the presentation. Yeah, and at the end I can just simply say, I'm going to destroy and take it all out. Now, I've shown you how to take these boxes, how to drop them onto your machine, how to run them. And I also shown you that there's Vagrant Cloud, which is a huge repository of many different boxes which people have already created for many different distributions, many different versions of these distributions. The question is, first of all, what if that box I want is not there? Or what if I don't trust them? Because these are really binary images which people have created and uploaded there. And what if you are really kind of a paranoid person who don't believe that these things don't have rootkits installed, they're not going to steal your password, things like that. What if you want to have your own box? It's possible. And the way to do this is through Packer, which is another tool I'm going to talk about. So Packer kind of complements Vagrant. It's a tool for creating machine images for multiple different platforms from a single configuration. Now, what is an image? Image is something. So if you have a machine, be it virtual machine or an actual laptop or server, image is this binary thing you drop onto it to make it working. So it's typically an operating system plus all the software which is pre-installed on the machine. Now, the problem is that there are many different image formats, and they change. They are different between platforms. So Vagrant file has one image format. If you use VMware, it will be a different one. Then if you go into cloud, CloudStack uses different one. Amazon EC2 uses different one. So actually every single cloud out there uses completely different image format. The nice thing about Packer is that it abstracts all these differences away and gives you again unified interface, which is relatively easy to use. Same as in case of Vagrant, there is a single file which drives the whole thing. In case of Packer, it's called Packer template. Which really describes how to build such a machine image. And there are three important concepts, three things you will find in these Packer templates. These are builders, provisioners, and post-processors. Builders, same as in case of Vagrant file, you need providers, which will give you the support for the different virtualization platforms you want to use. Builders, in case of Packer, are exactly the same things. These give you support for these underlying platforms you want to build these images for. So, one you would obviously expect is VirtualBox. This allows you to build new images for VirtualBox VMs. But there are also builders for things like Amazon EC2, Google Compute Engine, OpenStack, and others. At this point, you might actually notice that CloudStack is not on this list because at the moment it's not officially supported. But this is something I've been together with a couple of other people from Red Hat and Citrix we've been working on. And I already have a working version at the moment just on my laptop, but hopefully it's going to be out soon in a matter of weeks. And if you're interested in playing with Packer against our private cloud, I can actually give you a copy of this tool, this plugin. Provisioners, in case of Packer work exactly the same as in case of Vagrant. You have the same selection. And post-processors then, so I'll actually show you the whole image. So what you do is you start with a template, then Packer uses this template to create a machine, to provision it, and then to create image out of such finalized machine. And post-processors are these parts which create these images. At the moment there are two different processors, one for creating Vagrant boxes and the other one for creating Docker containers. Again, using Packer is really simple. Just creating a project, you create a template which is just a JSON file, and then once you fill it out with all the details, and in the end, you just say Packer build, and Packer will create, provision, and package your machine image, and it will end up with a Vagrant box, which you can then add in it, same as we've done before. I'll show you Packer later on. Just before I go there, let me just quickly go over cloud, because for cloud I only have, I think, 2 slides, because in my opinion, cloud is really, cloud really, in the end, lots of people see cloud as something new, awesome, completely different concept. But in my opinion, cloud is just, different ways, different names. So imagine you have a laptop, like this one, and you want to run a couple of VMs for your project. So, laptop like this one, which is, state of the art, decent laptop can run, 4, 5, maybe 6 VMs, and then you're done because you're simply out of resources. So you need more. So you buy more machines. And then the problem is that once you have these machines, here I have 3, but imagine you have 20 or 30 of them. How do you decide, if I want to run a new VM, how do I decide on which of these machines it should end up? And what if I have multiple people using all these machines at the same time, because that makes sense. You want to keep all these machines busy most of the time, otherwise it doesn't make sense to buy them. So what you do is you create some kind of manager, and which manages all these machines, and you wrap it up with an API, and you give this API to people for them to use, to communicate with this whole thing. And what you build yourself is a cloud. This is all there is. Now that's cool. This could be a private cloud, like clouds that we have down in the basement. But later on you decide, well, these 3, 10, 20, 30 machines, it's not enough. I really need more. I really need thousands. Well, not a problem. Just buy more. Well, not necessarily you. It could be Amazon or Google. And again, you add some management stuff below. You need some API on top. Bam, you have another cloud. Now, what you might notice, one of the issues is that these APIs tend to be different. Actually, in all cases, they are different. So API for talking to Cloud Stack, OpenStack, Amazon EC2 is completely different. And what's even worse is that while you want, when your project is ready, when you want to deploy onto these clouds to do some heavy computation, you want to go here. During development phase, you probably still want to use your laptop. You don't want to start developing it straight away inside the Amazon cloud. So it would be really nice if we could have some kind of, unifying layer or tool which would abstract all these differences away. And turns out there is, which is both of these tools I've shown you, Packer and Vagrant. And the way they work is, this is really the big picture. So you start with a template which says how to build a new image, how to build a new machine. From this template you build 3 different types of machines. One could be for your laptop when you use VirtualBox. One could be a private cloud, like the one we have here, which uses Zen server. Another one could be public cloud, Amazon EC2, when you don't even know what they actually use, and you don't really care what they use because it's an internal thing. As long as they have an API, it's fine. Then, optionally, if you need to, you provision this machine you just installed, and then Packer creates a box, which is something you then feed into Vagrant, and then from this box, you can create a new Vagrant file, which describes the setup for your project. Out of this Vagrant file, you can create a set of VMs, whether it's on your laptop or inside the cloud. You can provision them, and you can start running whatever you need to run on them, whether it's your project, whether it's your applications, everything. And that's about it. Why is it useful? Whenever people talk about cloud, they typically use these terms like platform as a service, infrastructure as a service. For me, DevOps in this sense is kind of like infrastructure as a code. And the reason is because all these fragments which are here, things like these templates or Vagrant files, are just text files. You can take them and you can store them in your Git repo together with your code. So they are not, you essentially turn a running machine, environment, into something which can be version controlled, something which many people can share and collaborate on. And it also enables for isolation, because you have one VM per project. These things don't interfere with each other. You have repeatability. If something works in box you have in your machine, you can take this box, you can send it to somebody else. That person can load this on his laptop and try the same thing. And verification, because you can use this to, for example, verify results. And I think all these concepts, of course they are important in industry, but they are also increasingly important in research. Because people always talk about, verifying our research results. There are all these conferences which have artifact tracks. And I think, these tools can be really helpful there. And just to end up with, this is what DevOps people say about DevOps, right? Just to summarize that, let's just go back to them. And I'm going to show you now. what I'm going to do is I'm going to run this because this thing takes quite some time, and in the meantime, as it's going to run, I'll try to explain you what this thing does. Okay, this is not something that's supposed to happen. This is always a problem of doing live demos, that things tend to break. Always. Alright, let's keep this running. It will take a while.
Can you show us that hackathon?
Sorry?
Can you show us that hackathon?
Yeah. So, first of all, what's inside this file I've just run? This is just a JSON file, which has which contains some variables, which says where to get these ISOs from. Not interesting. You can get these URLs from canonical other companies. There are two types of builders. One is for a virtual box. I'm not building that. If you've noticed, here I've said I only want to build an image for CloudStack. So let's look at the second builder, which is the CloudStack one. The second builder, which says I will be building image for CloudStack. These are just some configuration parameters which are very interesting, and then there are some IDs. I'll explain what this means, and then user data which describe how to actually boot this machine up and how to configure it. Then, after this is done, I will run some provisioners. In my case, I just use magic shell scripts. Again, just internal details. I can explain those in a bit more detail if you have some time in the end. And in the end, I have a post-processor. I say, in the end, I just want to create a Vagrant box out of this. This is what drives this thing, but there are other important things as well. So I have a scripts repo, which contains all these shell scripts, which then provision this machine. So for example, things like, when I create this machine, I want to install Docker onto it, because I'll be running Docker containers there. So there is a shell script which installs Docker there. There are other more important things, like for example, because this thing will be running on CloudStack, and CloudStack has some dependencies. For example, when you run a machine on CloudStack, you need to set up DHCP correctly. So I have a script which, after installation, will drop all the scripts, set up all the variables, everything necessary to actually run this thing on CloudStack. Cool thing is, it's not an easy thing to do, but if you do it once and you get it working, it's something you can take, you can drop into Git repo. And what I'm actually going to do, I'm going to take everything I've shown here, and I'm just going to drop it probably on GitLab. So every one of you can just take it and run it on your machine, and it will just work. There is nothing specific to my project. This is completely generic, and it will work for every single one of you. Then in HTTP folder, this is actually something which will be driving installation of this thing. There is one important file, it's called receipt, which actually, if you ever install Ubuntu or Debian, you know that when you start the installation, you have to go through all these steps, like say, how do you want to format your hard drive, how do you want to set up clocks, mirrors, everything. And this is a script which actually drives the whole thing for you. Now, this thing runs again CloudStack, which is this thing we have here down in the basement, which is our own local cloud. Now, there's already been talk from CSG about how to use this thing, how it works. Not sure how many of you follow that thing, how many of you follow that talk, how many of you actually managed to reproduce everything they've shown. So I just thought maybe I'll take a slightly different angle and show you things which are really important. So if you actually log into CloudStack, which can be done through cloudstack.doc/uk, you will see something like this, which shows all the running instances. Actually, this first one, this is the one I'm currently building, using this command I just executed a while ago. Or your storage images, networks, templates. Now the question is, if I want to use this from these tools like Vagrant or CloudStack, how do I talk to this thing? Normally, you would use username and password. That's not really the case for CloudStack. It's not like, I mean, you might have noticed that here when I've executed this thing, I've never provided username or password. I've never told CloudStack who am I. So how is it possible that this thing actually works without me telling it so? The way this is done is through a concept called API keys and secret keys. So if you want to use CloudStack, you need to go to accounts. Here you'll see your account. I'm not sure if this is visible. Let me try it. Yeah. See your account. You click on this thing. You'll see details of your account. Now, for some reason which is completely unknown to me, you have to select View Users, which brings you to a completely different pane, although it looks the same, similar to the previous one. Then you click on your name again, but you get to a different pane, and there are two important things. Well, there is this icon which says Generate Keys. So if you go there first time, these two fields, API key and secret key, will be empty. Once you click on Generate Keys, it will give you two long hashes. And these are your keys. This is really our credentials you will use to talk to CloudStack. This is how you identify yourself. And to actually use that, the way you do this is that most of these tools already are aware of this. So the thing you do is simply you will have something like a script I have here, which I've executed at the very beginning, called CloudStack Sage. And what this thing does, it simply takes URL of our cloud and those keys and just drops it, sets it up as a shell environment variables. So if you want to use CloudStack, communicate with it, the first thing you would do is you just drop, you just run something like this in your bash rc bash profile as the first thing when you log in, and then from that point on, you will be always able to talk to CloudStack without actually providing username or password. Just keep in mind, these things are equivalent to username and password, so it's not something you want to give out, not something you want to share with other people. Obviously, unless you want them to use the same thing. Now, second thing is so as you can see, I'm already using Vagrant itself myself to actually manage my environment. So I have lots of Vagrant boxes running around all different machines, different things running on different machines, which can sometimes be a little bit schizophrenic, but it works. Now, just go back. If you remember, in this builder file, which I've shown you before, there were all these IDs. Service offering ID, template ID, zone ID, disk offering ID. These are actually really important concepts when we talk about CloudStack. So if you actually go into the user interface, CloudStack, and you say, I want to create a new instance. This is the way you normally go as a regular user without knowledge of these tools. You say, I want a new instance, then I want to create a new VM from a template. I'll select this one, or well, not this one because this is just being currently built, but I'll select this one. I will select some, how performant my VM should be. So, combination of CPU and RAM. How much space do I need? Whether I want 25, 10 gigs, and what kind of network. There is no network connection at the moment. And in the end, just say launch VM, and I will get a new virtual machine. Now, when Vagrant or Packer do all this building, machine provision, everything, they need to do exactly the same thing. But they don't really use this interface. They use API, and they need to somehow identify all these things like these data disk offerings, compute offerings. And the way to do this is through these identifiers. So, for example, if I go to my template and if I open it up, you will see that there's an ID. This is exactly this thing I provide here. Okay, not in this case. So if you want to see what I provided there, if I select ISOs, here we This is A55A0782, which surprisingly is exactly what I've sent here. So when putting this image up, I'll be using it as ISO. For some things, it's actually quite easy to find them. Like, if you go to the list of your templates of your ISOs and click on them, you will simply see the ID. Problem is that for some things, like this compute offerings, how powerful your machine will be, there is no way to actually see them through this web interface. So you need some other way to do that. And unfortunately, there is no nice, clean interface. You really need to go back down to shell. And there's a tool called CloudMonkey, which is a command line interface to talk to CloudStack. You start this, you set up again. You provide CloudMonkey with the URL, with your API key or secret key, same as we did before, and then you run sync. CloudMonkey will connect to your CloudStack. It will download a list of all the APIs, and then it gives you, it allows you to actually list things which are provided by your CloudStack instance. So to show this, let me say list, and now, service offerings. How tab completion works, so you don't need to remember all names. And even if I say just list and I press tab, it will just give me everything I can list here. So what I want to see are what type of service offerings I have. And if I execute this, I'll see a list of all these offerings. Now these names are exactly those names you've seen back then in the web interface, but there is one other important thing that you really need when you use tools like Vagrant or Becker, and those are these IDs. This is the stuff you need. So when you are creating these templates, too many windows. Here. What you will do typically is you would decide what I'm going to use for my VMs. You would then use CloudMonkey to list all the offerings when it comes to disk space, when it comes to network zones, base templates, service offering IDs. You will get those IDs and we'll put them there. It's tedious, it's not a very nice thing, but again, the cool thing is you only do it once, because it's likely that for your whole project, you will want to use the same service offerings or the same disk size. You're not going to change these things every time you run a new VM. And once you've done this, it will be part of this JSON file, which you can then you can take and you can add to your Git repo of your project and just commit it in together with your source files. So then, when other developer in your project downloads those sources, he will also get the Vagrant file and he will also get JSON file, and he can build the same image and then run the same image using Vagrant, and he will get exactly the same environments as you had originally. It's not yet finished. Let me, in the meantime, so what I've created originally when I was showing you Vagrant, it was a very simple project, just a new one. Let me show you something more advanced. This is already a prepared one. So a few months ago we were running a project for analyzing different repos, and we were also using Vagrant to run our experiments. This is Vagrant file. It's very similar to the one I've had before. It uses precise as a base image, it sets up some sync folders, and then the difference is that it says you want to provision this thing using Ansible. So not shell scripts as in the previous case, but this time it will be Ansible. One of those frameworks I was talking about. Now, how does Ansible? I'm not going to go into details of Ansible. That would be another probably separate talk. Ansible is configured using YAML files, which describe all the things you want to drop onto this machine. Important thing is now when I say Vagrant up, Vagrant will again jump in. It will create a new machine. Let's go.
Just a quick question on what we showed earlier. So, do you install CloudMonkey on the VM or on the host?
On the host. This is really client. You don't really need it. This is more, for like querying or testing. Like if you actually have all these things set up, like Vagrant files and JSON files, you don't really need CloudMonkey anymore. I really use CloudMonkey when I need to list these IDs. I didn't, or for debugging. I never really had to use CloudMonkey for anything else.
it seems that you Vagrant SSH then maybe that's probably a...
Oh, well, actually, so this was on a different machine. I have a Cloud Monkey and I have it running in the Vagrant box.
Okay.
So whenever I need the Cloud Monkey, instead of just remembering what are the all commands I need to run, I just go to the machine, I connect into the Vagrant box, and I have the Cloud Monkey running there.
Right, okay.
So this is what I meant.
Now it makes sense. Because
I already use a lot of Vagrant boxes for, I have different boxes for different use cases. Why is this taking so long? It's actually another cool thing. I wasn't planning to demonstrate this, but yeah, anyways, if you kill this in the process, Vagrant is covered enough that it will clean up everything. In the meantime, this thing I've started initially finished. Now, what this thing does, this was back running, and it connected to our cloud, created a new machine. It went through the whole Ubuntu installation, installed the thing on the cloud stack. It ran all my shell provisioning scripts, then stopped the machine, created a new template, set this template, cleaned the whole thing up, and created a Vagrant box. Now this box is different from those other boxes I had, because those other boxes, those were virtual boxes, which would be huge, would be typically 5-10 gigs in size, because they would contain the whole image for a hard drive. This box only contains two things: Vagrant file and metadata, which only describe how to connect to cloud stack. Nothing else, because you don't really need anything else. Now, if I actually go to cloud stack and if I list my templates, I will see there is a new template available, and it's the one I just built. Well, to use this, what I do is, in the folder I've executed this before in this folder, and now you see this box was created here. So what I can do now is I can say Vagrant box add, let's name it cloud stack Ubuntu. I'll just add this. So now this box is installed. Vagrant is aware of it. Here it is. And now we need the Vagrant file. I've already prepared one in advance. Vagrant file for cloud stack is slightly a little bit more complicated than before, because you need to say if you want to spawn a new VM on a cloud stack on our private cloud, you need to say again what hardware you want to use, what zone you want to use, what network you want to use. And yeah, the box we'll be using is the one I just installed, cloud stack _Ubuntu. And these are the SSH keys and usernames I'll use to connect into this machine. And now I can simply say is Vagrant up.